In this video, we'll take a look at section 10.2, Law of Cosines. So to this point, we've taken a look at right triangles, and we've also looked at how to solve oblique triangles using the law of sines. Oblique triangles are those that are not right triangles. So we used for case 1 and case 2, if we were given two angles in one side, or two sides in the angle opposite one of them, we use the law of sines. So in this section, we're going to take a look at the next two cases. If we have two sides and the included angle, the angle in between the two sides, or three sides, we can use the law of cosines. So this formula is derived in your textbook. So if you want to take a look at that section and see where the formula comes from, it's in section 10.2. So the law of cosines, let me draw a triangle. If you have angle A, B, and C, the sides opposite, A is small side A, B, and C, the law of cosines talks about the relationship between the three sides and the angle across from the side. So if we take a look at the first iteration, little side A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of the angle opposite. So there are three iterations of the law of cosines, each one of them containing the side length and the cosine of the angle opposite. So let's take a look at a couple of examples. The first example is the case where we have two sides in the included angle. So if we want to solve the triangle with little side A 45, B 67, and C 35 degrees, draw the picture first, and we've got a diagram. Notice we have two sides and the included angle. So since angle C is known, we can first solve for little side C, the side across from angle C. So we're going to use the iteration of the law of cosines that uses C. So C squared would be equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. Substitute the values in. C squared is what we're looking for, is equal to little side A, which is 45 squared, plus side B, which is 67 squared, minus 2 times 45 times 67 times the cosine of angle C, which is 35 degrees. So we can type this all in the calculator, or you can do it in parts. C is going to equal the square root of all of that if we square root both sides. So I'm going to set up what side length C equals and then put it all in the calculator at the same time. Or you can use Desmos. So in the calculator, side length C is going to equal the big square root of 45 squared plus 67 squared minus 2 times 45 times 67 times the cosine of angle C, which is 35 degrees. So make sure that your calculator is in degrees. And I end up with 39.68 as the side length for C. So now that I've got C, solving the triangle means now I can find either angle A or angle B. So you can use the law of cosines again. If you want to find angle A, then use the iteration of the law of cosines that starts with A squared equals B squared minus or plus C squared minus 2 times B times C times the cosine of angle A. So since we're trying to find the cosine, you could set up your formula. We're going to take A squared, solve for the cosine of A, minus B squared minus C squared equals negative 2BC times the cosine of A. Divide both sides by minus 2 times B times C. So the cosine of angle A is going to equal a squared minus b squared minus c squared divided by negative 2 times b times c. So a in this case is 45, so we're going to take 45 squared minus b, which is 67 squared, minus c, which we just found to be 39.68 or 39.7, divided by negative 2 times b, which is 67, times c, which is 39.68, and that's going to equal the cosine of angle A. Okay, if you want to put it all in one shot, the inverse cosine of both sides is what we're going to take. The inverse cosine of this expression is going to actually give us our measure of angle A. So I might go ahead and just put it in the calculator all in one. So let's take inverse cosine of, I'm going to put parentheses around 45 squared minus 67 squared minus 39.68 squared. That's the numerator, end parentheses, divided by, parentheses, negative 2 times 67 times 39.68, end parentheses for the fraction, end parentheses to find the inverse cosine. So if we do all of that at once, angle A is approximately 40.58 degrees. Put it as much as you're comfortable in the calculator to make sure you're correct. What we're trying to avoid is rounding errors by rounding too many times in the problem. So once you have angle A, we already know angle C. We know that the three angles in a triangle have to have a sum of 180 degrees. So we take 180 degrees minus 35 minus the 40.58, and that will give us angle B. And we end up with 104.42 degrees, approximately. So round to as many places as you need to for the homework. So that's using the law of cosines. And keep in mind, once you find opposite sides or angles, you can also use law of sines. But I thought we'd first practice law of cosines in this section. All right, next problem. What if you have three sides? We want to solve a triangle where side length A is 226.14, B, C, draw your triangle, label your angles A, B, C, side opposite angle A is 26.14, these are all measured in kilometers. Angle B opposite is 21.39, and opposite angle C is 18.76. So in this problem, we have all three side lengths, so we have to find the angles. So we're going to use law of cosines. Select any angle. If you select angle A, then we're going to have the relationship A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So this is like what we did in the last section, or the last problem. If we subtract, solve for the cosine of A, we get A squared minus B squared minus C squared divided by negative 2 times B times C is equal to the cosine of angle A. So in this case, A is 26.14, so we have 26.14 squared minus B, which is 21.39, minus C, which is 18.76, divided by -2 times B, 21.39, times C, 18.76, is equal to the cosine of angle A. So again, we're going to take the inverse cosine of each side to end up with angle A. So if you're not comfortable putting it all in at once, you can go ahead and just find the cosine first. 26.14 squared minus 21.39 squared minus 18.76 squared in parentheses divided by parentheses -2 times 21.39 times 18.76. And we end up with 0.1572109, etc. So we're trying to find the inverse cosine of that, 0.1572. So I want to put it in, if you're not going to do it all at the same time, I want to find the inverse cosine and put in as many decimal places as possible. 0.157211 is probably okay for this one if I round it. So that'll give us about 80.95 degrees. So angle A is approximately 80.59 degrees, or 95. So that's 80.95 degrees. Just erase that. So to find angle B and angle C, you can do exactly the same thing. So I won't work the whole thing out, but if you want to find angle B, then set up B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. Follow the same steps to get angle B. And then once you have two of the angles, to find angle C, take 180 degrees minus angle A minus angle B. All right, so let's take a look at an application problem from the section. All right, so there was a problem at the beginning of the section that talked about a boat leaving port, traveling 10 miles. So the boat leaves port, travels 10 miles, turns 20 degrees, so we're turning 20 degrees, and travels another 8 miles. So this represents the path of the boat. Then how far from the port is the boat? So if we make a dotted line, what we're trying to find is this distance x. So we have 8 miles, we have 10 miles, and we don't have the angle in the oblique triangle, but we can find the angle. We know that the straight angle is 180 degrees. So 180 degrees minus 20 degrees gives us the angle in between these two side lengths, which is 160 degrees. So now we have a triangle that has two side lengths and the included angle, and we're looking for the side opposite. So that tells us that it's the law of cosines. So to find our length x, x squared is going to equal the side length 8 squared plus the side length 10 squared minus 2 times 8 times 10 times the cosine of the angle in between, which is 160 degrees. So x is going to equal the square root of all of that. So we type it in the calculator all at once to make sure we don't have any rounding errors. I get the square root of 8 squared is 64 plus 10 squared, which is 100, minus 2 times 8 times 10 times the cosine of 160 degrees. And we end up with about 17.73 miles. All right, and that's the how to use the law of cosines for oblique triangles.